Bright QT. Every student matters.
Let's move to the exercise. A, B, C are 3 points on a circle with center O such that angle BOC is 30, that is this angle, and angle AOB is 60, that is this angle. If D is a point on the circle other than the arc ABC, so on the remaining part of the circle, find angle ADC, that is this angle. So obviously this angle D is half of this angle, because if I talk about arc AC subtends an angle of 90 degrees at the center, so it will subtend half of 90 degrees at the remaining part of the circle. So this angle is going to be 45 degrees. So the statement I'll write is angle ADC is half of angle AOC. Okay, the reason I will write is angle subtended by an arc at the center of the circle, is double the angle subtended by it at the remaining part of the circle. Okay, I am not writing the complete statement, so you write this statement that I have just spoken. So angle ADC is half of angle AOC. What is angle AOC? It is sum of, what is angle AOC? It is sum of angle BOC and angle AOB. So 30 plus 60, that is 90 degrees. Hence I will say angle ADC is half of 90 degrees, that is 45 degrees. Okay, otherwise these questions are 10-second questions. If you just observe it carefully, the figure, you can directly say that this angle is 45 degrees, but in examination you will write these statements. Okay, so some of the questions I might tell you in brief. Okay, I'll make you visualize the problem and see the answer, then you can write the rest of the statements yourself. A chord of a circle is equal to the radius of the circle. I have talked about such a circumstance previously, that in this case this chord, if it is equal to the radius, let us say this is the radius, this is R, this is R, so this chord is also R, so it will subtend an angle of 60 degrees at the center, because this will become an equilateral triangle. So let's read the question. Find the angle subtended by the chord at a point on the minor arc and also at a point on the major arc. So we are here to find this angle. Let us say this is theta. So we need to find theta, and we will also find this angle. Let me change the color so that it is easier for you to see the angle. This angle. Let us say this angle is angle alpha, or let us choose another name so that we do not confuse it with this R here. So let us say this is angle beta, so we need to find angle beta and angle theta. So the first statement we will say OAB is equilateral. What equilateral? It is an equilateral triangle. So angle AOB is equal to 60 degrees. Okay, the next statement that you will write is, let us name this point as B. Angle APB will be half of angle AOB. Then you will write the reason. What is the reason? That angle subtended by an arc, which in this case is arc AB, at the center is double the angle subtended by the same arc at the remaining part of the circle. So angle APB, which is theta, is half of angle AOB, which is 60 degrees. So theta is equal to 30 degrees. First part of the question. Now I need to find angle beta. So if I name this point as Q, I know quadrilateral AQBP is cyclic quadrilateral. right? Because all these vertices A, Q, B and P lie on a circle. So angle beta and angle theta are supplementary. So beta plus theta is equal to 180 degrees, opposite angles of a cyclic quadrilateral, right? So theta I already know is 30 degrees, so beta will be equal to 180 minus 30 degrees, that is 150 degrees. So the second part of the question is also done. So angle subtended at the major arc, that is at this point P, is 30 degrees, and angle subtended at the minor arc, that is at point Q, is 150 degrees. In figure, angle PQR, that is this angle, is 100 degrees, where PQR are points on a circle with center O. So we have to find angle OPR. So we are looking for this angle here. Okay, tell me about OP and OR. These are equal because both of them are radii of the same circle. OP is equal to OR because these are radii of this circle. So if this angle is alpha, what will be this angle? This angle will also be alpha. Base angles of an isosceles triangle. So angle OPR is equal to angle ORP, which I have taken as alpha. Why? Base angles of an isosceles triangle. Which triangle? Triangle OPR. Okay, this is one thing. Now I want you to visualize this. If this angle is 100 degrees, what can you say about any angle in this segment? For example, this angle. What can you say about this angle? If I take this point as M, quadrilateral PMRQ is cyclic, so angle M is equal to 180 minus angle Q. So this angle will be equal to 80 degrees because this angle and this angle are supplementary angles. Why I want to find this angle? Because I am looking for this angle here, which is double of this angle. Okay, so it is equal to 180 minus 100, that is 80 degrees. Hence I can say angle POR, which is double of angle M, will be equal to 160 degrees. Now in triangle POR, this angle, that is 160, plus the remaining two angles, their sum is equal to 180 degrees because of the angle sum property. So 2 alpha is equal to 20 degrees, hence alpha is equal to 10 degrees. So my answer for this angle is 10 degrees. So what I have done here is, this part of the figure was given that this angle is 100. I wanted to find this angle so that I could find this angle alpha. So I knew that this angle is alpha, so this angle will also be equal to this because this is an isosceles triangle here. So if I could find this angle, I will easily find these two angles. To find this angle, I made this little construction of drawing this PMR and completing this quadrilateral, which is cyclic quadrilateral. So if it is 100, this will be 80, and this angle will be double of 80, that is 160. So these two angles will be 10 degrees each. I hope you have got the point. Now in this figure, ABC is 69, ACB is 31, angle BDC is to be found. So we need to find this angle theta. Okay, so look in triangle ABC. Angle A plus angle B plus angle C will be equal to 180 degrees. Why? Because of the angle sum property of a triangle, right? So angle A plus, what is angle B? It is 69 degrees. I'm talking about triangle ABC. So this is angle B and this is angle C. So 69 degrees plus 31 degrees, it is equal to 180. What is 69 plus 31? It is 100. So angle A is equal to 80 degrees. Why? 180 minus this 100. So angle A is 80 degrees. If angle A is 80 degrees, look at the arc BC. Arc BC subtends angle A and angle D in the same segment of the circle. Hence, angle A is equal to angle D. So, theta is equal to 80 degrees is my answer. Okay. And the points A, B, C and D are 4 points on a circle. That means if I make a quadrilateral ABCD, then it will be a cyclic quadrilateral. If I join these A and D, now this is a cyclic quadrilateral. AC and BD intersect at point E, okay, such that angle BEC is 130 and angle ECD is 20. So we need to find angle BAC. So let us locate that angle first. I am talking about this angle here. I need to find angle theta, angle BAC. Okay, so now let us look at this angle first. This angle is a linear pair of this angle, so it will be equal to 50 degrees, right? So first statement I'll make here is angle DEC plus angle BEC is equal to 180 degrees, linear pair, and angle BEC I already know is 130. So angle DEC is equal to 180 minus 130, that is 50 degrees. Okay, so if it is 50, then this angle will also be 50 degrees because these are vertically opposite angles. So angle AEB is also 50 degrees because vertically opposite of this angle DEC. Okay, so if you write this much, now you focus on this arc AD. It makes an angle of 20 degrees here. So if I want to ask you about this angle, what will be this angle here? This will also be 20 degrees. Why? Angles made in same segment. Angle ABD is equal to angle ACD is equal to 20 degrees. Why? Because these are angles in the same segment made by or subtended by chord AD, right? So this is also 20. Now look at this triangle. In triangle ABE, theta plus 50 plus 20, it is going to be equal to 180 because of the angle sum property of a triangle. So theta is equal to 180 minus 70, that is 110, right? So this angle here is 110, right? Or the other way that you could have done this question, once you have found that this angle is 50, this angle is 20, so what is this angle? This angle is 110. Then you could have said that arc BC subtends this angle 110 at D, so it will subtend an angle 110 at point A also. So this could be another way of solving this question. Okay. ABCD is a cyclic quadrilateral whose diagonals intersect at point E. So let us make the cyclic quadrilateral first, so that it is easier for us to visualize the problem. This is a rough diagram obviously. So A, B, C, D, it is a cyclic quadrilateral whose diagonals intersect. So AC and BD intersect at point E. Now angle DBC, that is this angle, it is 70 degrees. Angle BAC is 30, that is this angle, it is 30. Find angle BCD. So I am going to find this angle here. Okay, this is the first part of the question. So let me show you what will be this angle. This angle is equal to this angle. Why? Because if you talk about this arc here, arc CD, it subtends equal angles at point B and at A. So this angle here, angle DAC, if I name it theta, theta will be equal to 70 degrees. Then the reason is angle subtended by arc DC at points B and A are equal. Okay, so you write this statement yourself. I am just writing theta is equal to 70 degrees. Now I know angle A is equal to theta plus 30, that is 70 plus 30 equal to 100. Now if I know angle A is 100 degrees, can I comment about angle C? Yes, angle C is just the supplementary angle of angle A. Angle A plus angle C is equal to 180. You will write the reason. Opposite angles of a cyclic quadrilateral are supplementary. So angle C is equal to 180 minus angle A, that is 100. So it is equal to 80 degrees. So this is first part of the question. Now AB equal to BC. So if it is given that AB is equal to BC, find angle ECD. Which angle is this? Angle ECD, that is this angle. Let us name it as alpha. Okay. Now see, this AB is equal to BC. So what does it mean for us? That this triangle ABC is an isosceles triangle. So if it is 30, then this angle will also be 30 degrees, right? If we know this much, we can just subtract 30 from this 80 to find alpha. So alpha is equal to 80 minus 30, that is 50 degrees. Okay, how did I get this 30? Because of this triangle ABC being isosceles triangle. So you can write triangle ABC is isosceles. That makes angle BAC equal to angle BCA, base angles of an isosceles triangle. I hope you can write these arguments yourself. Okay, and this question is clear to you. Let us proceed to the next question without wasting any more time on this question. If diagonals of a cyclic quadrilateral are diameters of a circle through the vertices of the quadrilateral, prove that it is a rectangle. So if there is a quadrilateral, any quadrilateral, and if you can prove that all its angles are 90 degrees, then it will be a rectangle. So if you can prove in a quadrilateral, if you can show that all its angles are 90 degrees each, then it is a rectangle. So this should be clear to us. Now I just need to show that its angles are 90 degrees each. Diagonals are diameters of the circle. So this is one diameter of the circle. This is another diameter of the circle. Now see, let us say this is quadrilateral ABCD. Diameter BD subtends angle A equal to 90 degrees at the circle, because angle in a semicircle is 90 degrees. So what I want to say here is that BD being the diameter, this angle here will be 90 degrees because of angle being in a semicircle. Now because BD is a diameter, this angle will also be 90 degrees because this angle is in other semicircle, and because AC is the diameter, this angle is 90 degrees, angle made in a semicircle, and similarly this angle is also 90 degrees because this is also an angle in a semicircle. So all four angles can be easily proven as equal to 90 degrees. Diameter BD subtends angle A equal to 90 degrees, also angle C equal to 90 degrees, angles in a semicircle. Similarly, this is short form for similarly, I am writing it for you, you can write similarly. Angle B is angle subtended in a semicircle by diameter AC, so it is equal to 90, and angle D is also 90 degrees because of the same reason. Hence I can say quadrilateral ABCD is a rectangle. Okay, I hope the reasoning is clear to you. If the non-parallel sides of a trapezium are equal, then prove that it is cyclic. So to prove a quadrilateral to be cyclic, it is enough to show that opposite angles of the quadrilateral are supplementary. So it is enough to show, let me name these A, B, C, D, that angle A plus angle C is equal to 180 degrees, or angle B plus angle D is equal to 180 degrees. You can show any of these, either this or this, because if you can show this, then this will automatically be true because of the angle sum property of a quadrilateral. Now let us look at the given condition. Non-parallel sides are equal. Let us say AB is parallel to CD and AD is equal to BC. So I want you to do a little construction here, and the question can be solved in seconds then. I want you to draw a line parallel to line AD from this point B. And as soon as you draw this line, let us say this is line BE, draw BE parallel to AD. As soon as you draw this line is parallel to this line is parallel to this line. So what is ABED? ABED is a parallelogram. ABED is a parallelogram. Hence, I can say AD is equal to BE, opposite sides of a parallelogram. So, AD is equal to BE. Now see, AD is given as equal to BC, AD is equal to BE, we have just shown. Now these will tell me that BE is equal to BC. So this triangle BEC is an isosceles triangle. So this angle, hence angle E is equal to angle C. So if it is theta, this angle will also be theta. Base angles of an isosceles triangle, right? So if it is theta, this is also theta. Now look at this diagram. This is a parallelogram. So if this angle is alpha, what will be this angle? This angle will also be alpha. In parallelogram ABED, angle A is equal to angle E. Why? Opposite angles in a parallelogram are equal, right? Now when I say angle E this time, it means angle BED. Angle BED, because I am talking about in parallelogram ABED. So this E and this E is not same. So it is better that you call it BED, or we can say angle BAD is equal to angle BED, and I have taken both of these angles as angle alpha. Now once you know this much, this angle and this angle form a linear pair. So alpha plus theta is equal to 180 degrees because these form a linear pair, right? Hence I can say this angle, which is angle A, and this angle, which is angle C, is also 180 degrees. How could I say that? Because this is theta, this is alpha, and I have shown here that alpha plus theta is 180. So angle A plus angle C is also 180. which is enough for me to say that quadrilateral ABCD is a cyclic quadrilateral. Hence, quadrilateral ABCD is cyclic, right? So when I get this isosceles trapezium. Why do I call it isosceles trapezium? Because its non-parallel sides are equal. What I did is I draw this BE parallel to AD, making this ABED a parallelogram. So this angle alpha is equal to this angle alpha, right? This being an isosceles triangle, this is theta, so this is theta. Now I know these are linear pair. Theta and alpha form a linear pair. So theta plus alpha is 180. Hence angle A plus angle C is 180 degrees. This looks a difficult diagram, but let us read the question, because generally the difficult looking diagrams are very simple. So two circles intersect at 2 points B and C. Okay, these are two intersecting points of intersection. Through B, two lines segments ABD and PBQ are drawn. Okay, this is ABD, ABD and PBQ to intersect at ADPQ, right? We can see it in the figure. Prove that angle ACP, let us focus on the angles which we need to prove as equal. Angle ACP, that is this angle. Let us say this is alpha and it should be equal to angle QCD. So this is beta. We have to prove that angle alpha is equal to angle beta, right? Now for a moment, just look at this figure and focus on these two angles, this angle and this angle. What can you say about these two angles? Are these equal or not? Yes, these are equal. So why? Because these are vertically opposite angles. So angle PBA is equal to angle DBQ. Why? Because these are vertically opposite. Once you know this much, this question is done. Why? Because this angle alpha and this angle PBA are made by this arc, are subtended by this arc AP on the same circle in the same segment. So angle PBQ is equal to angle alpha. Angles subtended by arc AP in the same segment of a circle. I hope this reason you can write yourself. So PBQ is alpha and angle DBQ is equal to beta. This time angle subtended by arc DQ. So I am considering this arc here, DQ. It subtends an angle here and another angle here in the same segment of this circle. So these have to be equal. Now I know that these two angles PBA, this was angle PBA, this was angle PBA. Angle PBA and DBQ are equal. So because of this, I can say alpha is equal to beta, hence proved. Okay. If circles are drawn taking two sides of a triangle as diameters, prove that the point of intersection of these circles lie on the third side. So what this question means is, let us say these are sides of a triangle and taking this as diameter, a circle is drawn. So there will be this semicircle here, and to complete this circle, this is one circle with this diameter. This is the diameter, so I can say, I can already visualize that this angle here, this angle is 90 degrees because I am taking this as diameter. Okay, let me now take this as another diameter and draw another circle here. So if I draw a circle here, taking this side as diameter, This side has diameter. What will be this angle? This angle will also be 90 degrees. Now, what I mean is, if this is triangle ABC, taking AB as diameter, if I draw a circle, then angle AMB will be a right angle, because angle in a semicircle, right? Now, same about this side AC. Taking AC as diameter, I draw another circle, so angle AMC will also be 90 degrees. Why? Because angle in a semicircle is a right angle, right? This is the reason. Now, I know angle AMB plus angle AMC is equal to 90 plus 90, that is 180 degrees. So, which means M, or which means that this is a straight angle. So, what it means is BMC is a straight line, or in other words, M lies on line segment BC, right? This is what we had to show, that their point of intersection lie on the third side, right? It will lie on the third side. Why? Because if I make a circle, if I draw a circle on this diameter, okay, it will make this angle 90 degrees. Now, if I use this as my diameter, it is necessary for the circle to pass through this point. Why? Because in this, using this as diameter, this angle has to be 90 degrees, angle in a semicircle, and this angle is already 90 degrees. So, this point has to be a point on this circle also, and I have shown you, because this is a linear pair, BMC is a straight line, right? Now, ABC and ADC are two right triangles. ABC and ADC are two right triangles with common hypotenuse AC. Okay, let us look at this. The common hypotenuse is AC, right? So, let it be the first right triangle, and this another right triangle is ADC, okay, and common hypotenuse AC. Prove that angle CAD, that is this angle, is equal to angle CBD, that is this angle. It is very easy for us to show. Why? Because we know that ABC and ADC are two right triangles with common hypotenuse AC. So, this angle here, because AC is hypotenuse, so this angle is 90 and this angle is also 90, right? And if sum of opposite angles of a quadrilateral is 180, then that quadrilateral is a cyclic quadrilateral. So, if I draw a circle, it will pass through A, B, C and D. And if A, B, C and D are concyclic, then I can talk about this arc CD. It makes or it subtends an angle, this angle at the circle. If this is alpha, this angle will also be alpha, because it is also an angle subtended by the same arc in the same segment of the circle. I hope you have understood how we will go about this proof. So, once I draw this figure, I will say angle B is equal to 90 and angle D is equal to 90, because AC is hypotenuse. So, angle opposite the hypotenuse is a right angle. So, angle B plus angle D is equal to 180 degrees. Hence, A, B, C and D are concyclic. So now complete the circle and then consider arc CD. It subtends angle CAD and angle CPD in the same segment of a circle. Hence, these angles CAD and CBD are equal, right? Prove that a cyclic parallelogram is a rectangle. So, if you have got a parallelogram, how can you prove that it is a rectangle? Or when would a parallelogram become a rectangle? If we prove any one angle equal to 90 degrees, then this parallelogram will be a rectangle for sure. Okay. Now let us take a cyclic parallelogram. Let us say this is the cyclic parallelogram. So when I say cyclic quadrilateral, what I mean is that sum of opposite angles is 180. Angle A plus angle C is 180. Angle B plus angle D is also 180. So I am just considering this for a while. Angle A plus angle C is equal to 180 degrees. Now ABCD is a parallelogram. Hence angle A is equal to angle C. Opposite angles of a parallelogram. Now I have considered two things. Because it is cyclic, the sum of opposite angles is 180 degrees. And because it is a parallelogram, the opposite angles are equal. Once you have done this much, now what you can do is you can replace this A in this first equation by C. So angle C plus angle C is equal to 180. Twice of angle C is 180. Hence angle C is equal to 90 degrees. And if you have proved that one of its angles is 90 degrees, a parallelogram becomes a rectangle. Hence parallelogram ABCD is a rectangle. I hope this is clear to you. I have used these two words. It was cyclic, so I took the opposite angles as supplementary. It was a parallelogram, so I took opposite angles as equal. And by comparing these two things, I could determine that one of its angles is equal to 90 degrees. I can also show you that all of its angles are 90 degrees, which is very easy, right? But it is enough for you to show that one of the angles is 90 degrees in a parallelogram for it to be a rectangle. Okay, so I hope the chapter of circles is clear to you, and after doing all these exercises, you are very comfortable in doing the questions on circles, and just by visualizing the diagram you can see the answer and then write all these steps to fetch the marks, right? In the next lecture we will do an optional exercise. Thank you.